charge is distributed within a sphere of radius r with the volume charge density rho of r. Okay, a sphere is there, its radius is capital R, and its volume charge density is given by rho of r is equal to a by r square e power minus 2r by a, where a and small a are the constants. Okay, in this case you can see the density of the charge density of the sphere is not uniform. Okay, so it is the function of, or it is the function of the radius. Okay, so if the r value changes, density also changes. You can see rho is inversely proportional to r square, so the charge density is maximum at the center and minimum at the outer area. Okay, so the radius increases, the charge density will decrease. Okay, so it is maximum at the center of the sphere and minimum at the outer edge of the sphere. In this question we have to find the relationship between r and q. We have to make a formula or expression for r in terms of q. Okay, so we cannot directly find it because the charge density is not uniform. If the charge density is uniform, we could have used this formula. Okay, rho is equal to q by v, and the volume of the sphere is given by 4 by 3 pi r cube. If we rearrange this, we will get a formula for r. Okay, r is equal to 3q divided by 4 pi rho whole power 1 by 3. Okay, if the value is, sorry, if the charge density is uniform, we would have used this formula. Okay, but in this case the charge density is given as a function of radius. Okay, so this value changes along with the radius, so we cannot use this method. Okay, so we have to use some other method. Okay, so let me erase this. First I have to consider the sphere. This part is center of the sphere and its radius is capital R. This is the actual radius of the sphere. So what I'm going to do is I'm going to consider a small volume element dv at a radius r. Okay, small spherical volume element dv, its volume is dv at the radius r. Okay, and the thickness of this volume element is dr. Okay, the total charge inside the sphere is capital Q. So for the smaller portion I'm assuming the charge is dq. Okay, let me consider the small volume element. For the small volume element, the amount of charge present in the small volume element is dq. Okay, I can write that as charge contained in the small volume element is dq and its volume is dv. Okay, and the density of the element at the radius r, you know, the radius of the smaller element is r. Okay, so the density of the element at r is given by rho of r. Okay, rho of r, that is given in the question. Now we have to relate all these things, the formula. Okay, what is the formula for volume charge density? Rho r is equal to amount of charge contained in given volume. Just rearrange this, you will get dq equal to rho of r into dv. Okay, now I framed the equation for charge contained in the smaller volume. Okay, now I have to use this equation to find the amount of charge contained in the entire sphere. Okay, so for that I have to do integration. I'm integrating these two on both sides. Integrating on both sides. Okay, I will get integral dq equal to integral rho r into dv, and the limit for integration, the charge value varies from 0 to q, right? The value of charge varies from 0 to capital Q. The total charge is 0 and it increases to q, amount q. Okay, and the same thing, the initial radius is 0 and the overall radius, final radius is capital R. Okay, at the center the radius value is 0. Okay, so when you move from center to the outer surface of sphere, the radius value changes to 0 to capital R. So that's why I am using this. Now substitute the values. On integrating this, you will get q 0 to capital Q. On the right hand side, before integrating, you have to substitute the value of rho given in the question, that is a by r square e power minus 2a 2r by a. Okay, a divided by r square e power minus 2r by a into dv. Here you cannot integrate this because the value, the variable here is r, but we have v here. Okay, these two should be same to integrate. So what I'm going to do is I'm just going to convert this dv into dr. Okay, so it will be easy. I'm writing the formula for volume of sphere, 4 by 3 pi times r cube. I need the value of dv, but I have here is v. Okay, so to convert v into dv, I have to differentiate this. So dv by dr is equal to, I am differentiating the volume equation v with respect to radius r. So I will get 3r square. Now you can cancel 3 and 3, you will be left with 4 pi r square. From this you can find the value of dr. Just take this dr to the right side. Dr is in division. If it goes to the right, it will become multiplication, r square into dr. Now we can use this value here instead of this. So we will get 0 to r a divided by r square e power minus 2r by a into 4 pi r square into dr. Okay, so I'm just erasing this. Now you can see, you can cancel the r square with r square, so you will be left with only 0 to r a into e power minus 2r by a into 4 pi into dr. Okay, 4 pi and a are constant, you can take that out. 4 pi capital A 0 to r e power minus 2r by a into dr. Now you can integrate this. 4 pi a into e power minus 2r by a divided by minus 2 by a. Limit is 0 to r. Okay, so I just used the formula integral e power ax into dx is equal to e power ax divided by a. So you have to divide the coefficient of x. Okay, so just write the term here, whatever the term, just rewrite the term and divide the value with coefficient of x. Okay, you can rearrange this formula. 2 by a is constant, it is independent of the r value, you can take that out, so you will get minus 2, you can put the a in the numerator, e power minus 2r by a, r2 0. Let me do this left hand side first and then we can do it simultaneously. If you replace the upper limit, you will get q and the lower limit value is 0, so simply you will get q here. Okay, and the q follows still here, and then we have to apply the limit on this side. Before that, we can take the remaining terms to this side. You will get minus 2q divided by 4 pi a into a is equal to e power minus 2 into, first time applying the upper limit, e power minus 2 into 0 by a. Okay, and then you can cancel the 2 and 4, you will get minus q by 2 pi a is equal to e power minus 2r by a, anything power 0 is 1. Okay, you will get e power 0 here, e power 0 is also 1. Let me take the minus 1 to the side. That will become plus 1 and you will get e power minus 2r by a, and then you can just rearrange these two. You will get 1 minus q divided by 2 by a into a. So I have just rearranged this, and in the power of e you have a minus, so you can take this to the denominator. You will get e power 2r by a. Let's take the reciprocal on both sides. You will get 1 divided by 1 minus q divided by 2 pi a. So I have taken reciprocal on both sides, e power 2r by a. So because I have to find the value of r, capital R. Okay, so whatever the value that we should find, that should be in the numerator, it should not be in the denominator, and there won't be any negative signs on that too. Okay, to remove the negative sign, I have taken the I took that value to denominator and then I have taken reciprocal on both sides. Okay, now to remove the exponent, we have to take log on both sides. Applying log on both sides, you will get log of 1 divided by 1 minus q divided by 2 pi a is equal to 2 times r by a. I need the value of r, I don't need the value 2 and a here, so I can take this to this side. I will get this 2 by a will become a by 2, a by 2 log of 1 divided by 1 minus q divided by 2 pi a equal to capital R. So that's the required answer. Check which option it contains. This is in option B.